Okay, so harvest and storage performance issues, basically it comes down to 3 or 4 factors. And obviously the key one, I believe, is variety, because we've tested probably 12 to 15 different varieties over the 3.5 years, and they can behave quite differently, even under the same temperature and storage conditions. Some are much more susceptible to storage disorders, as in flesh browning and mealiness during long-term storage or during sea freight export. And the reality is although we're probably covering familiar ground in terms of some of our trials, there's very little information about a lot of the new varieties that we're growing specifically for export and the domestic market. So I don't think we're treating new ground because we really don't know a lot about these cultivars in terms of how they perform, after harvest. So we've found some, and you'll see we've found some interesting results. The other issue is that basically a lot of these varieties we're sea freighting, and the reality is that sea freight is taking between 3 and 4 weeks, just the sea freight component. It's not 3 weeks, it's not 21 days, it's generally well beyond that before they arrive at the importer overseas. So these cultivars, some of these are unlikely to actually be, sea freighted successfully because of these storage disorder issues. And then you might have the importer storing the fruit for 1 week or more, waiting for the right time to market the fruit. So that is a major issue, that duration from harvest right through to arrival at the importer can be beyond 4 weeks. Then we've got harvest maturity and the inherent variability of the fruit you're harvesting. And this is an example here just of, in terms of sugars at harvest for Majestic Pearl. And this is fruit has been graded, is ready for export. And you can see the variation in soluble solids. And we've been finding that up to 25% of fruit in a particular cultivar is lower than what we would term, acceptable in terms of sugars. So you can find quite a bit of variability even in soluble solids and sugars. And the other issue that we've had is limited temperature monitoring, particularly before export and after export. So during importer storage and beyond into retail. And Glenn's been doing a lot of work in that area over the last few years. So I'll very briefly mention harvest maturity because Christine will be going into it, but we've done a lot of work looking at the effects of harvest maturity. So there's a diagram of September bright, I think, and categorizing a batch of fruit by the actual physiological maturity. So this would be considered the onset or commercial maturity, harvest maturity, unripe, overly ripe. Obviously, you can't tell any difference between them visually, but physiologically, they're quite different. And this is the type of data we collect. Storage over 6 weeks at 2 degrees. And then after each storage period, we ripen the fruit. And these are the 3 maturities. So what we would term unripe fruit, commercial maturity, and then overripe fruit. And you can see the difference in behaviour as we move along the storage period. As I said, Christine will be talking much more about that, specific cultivars and optimum harvest maturities. And then Glenn will be discussing in detail export temperature monitoring. Some of the, very generally, what we found is with air freight, we do get variable temperatures over that actual air freight period of 24 to 48 hours. So variable temperatures and spiking temperatures, 8 up to 12 degrees over that short period. And we don't really know the effect of these short and high temperature spikes, although in a little while I'll show you what the effect is likely to be, because we've conducted air freight simulations and used a few high temperatures to see if there's any impact on quality later on. And then sea freight, The sea freight leg, because of disinfestation protocols, is always good, below 3 degrees for 21 days and beyond. But the major issue we found is that sea freight leg is taking way too long, greater than 27 days, and can be up to 35 days between harvest and getting to the importer, which is, in my opinion, a little bit ridiculous. We can't expect the majority of cultivars we're growing to actually store that long and then ripen properly. I mean, that's a major issue. Okay, so let's move on to what we're going to focus on today. And in general, what we've found, and this is probably common knowledge, in terms of general storage behaviour by fruit type and variety, well, if we look at early season varieties, then mid-season and then late, you tend to get increasing storage potential due to reduced softening. So the early season varieties tend to soften more quickly, even at lower temperatures, and I'll show you some data demonstrating that. But you also get increasing susceptibilities to storage disorders as you move later into the season. In terms of type of stone fruit, well, the white flesh tend to be have less storage potential than the yellow white flesh peach. Then somewhere in the middle, I categorise the yellow flesh peach and white flesh nectarine as to having sort of average storage potential, and then your yellow flesh nectarine tends to have greater storage potential. But again, even though we know that white fleshed varieties tend to be susceptible to storage disorders, in fact, the later varieties, whether they're white or yellow, again tend to be a little bit more susceptible. And then you've got factors like tree age in the order, whether young trees or older trees, orchard climate, warm weather versus cooler climate orchards or regions, melting versus non-melting, although we don't really, as far as I know, really grow melting varieties anymore. So there are other factors, but these are what we've generally observed. Okay, so in terms of storage behaviour among varieties, here we have 4 varieties. So we've got the table here: very early yellow nectarine, June sweet; an early white nectarine, polar light; an early white nectarine, diamond pearl; and a mid yellow nectarine or mid to late yellow nectarine, September bright. These are the harvest furnaces that when we ran these trials, so they're all around the 6 to 6.5 kilos at harvest. What I'm plotting here is the change in fruit firmness from these initial harvests during storage, so days in storage up to 25 days here. And this is storage at 2 degrees, and the final, and you can see how the fruit softens, or how much the fruit softens from the start. If we call the harvest firmness 100, then you can see the differences in how the different varieties behave. June sweet, you lose 60% of initial firmness over that storage period at 2 degrees. Whereas, for example, September bright, there's very little change in firmness. And then you've got your early white nectarines are somewhere in the middle. So you can see what a large difference cultivar variety makes to storage potential, even at this sort of close to optimum 2 degree storage period. Down here, we've got storage at 8 degrees, which is obviously far above optimum, but just to demonstrate the same effect, same 4 cultivars. Yes, you lose 50% of your firmness after 12 days in September bright, but it's the other earlier varieties, whether they're white or yellow fleshed, you're losing 75% of your firmness at 8 degrees, which is to be expected. But again, to demonstrate there are differences purely based on variety. So it's very clear that variety is one of the key aspects of determining storage potential. And although we've done work for a number of varieties, I think there's still a lot of work to be done to really understand how these varieties perform and which ones are limited in terms of export. The other thing we've found in a lot of our work is storage disorders, mainly flesh browning and mealiness caused by chilling injury, which is usually related to storage duration. And for example, this photograph is of Majestic Pearl. And here we've got a sea freight export simulation. The actual sea freight was 28 days. We conducted it at Agri-Bio-Centre in our cool rooms, and we had different importer storage temperatures. So once the fruit arrived, we simulated importer storage at 4, 8 and 12 degrees. But as you see, at the end of sea freight and there was no sign of flesh browning, but after 4 days of importer storage, 4 to 5 days, you already started to get this kind of browning occurring. And it really didn't matter, end of retailing and then ripening, there was flesh browning consistently. And this picture down here is Flavour Pearl, which is the white nectarine that comes in before Majestic Pearl, and around the same part of the export chain, no flesh browning. So a big varietal difference with very similar, I mean, they come in at around the same time and they're both white flesh nectarines, but the performance is completely different. And just highlighting a little interesting thing that we've noticed in quite a few trials, have a close look at these. This is after 48 hours of ripening. And this trend is very similar across. Importer storage at 12 degrees actually reduce the incidence of flesh browning compared to the lower temperatures. And I'll be discussing that more in 2 weeks when I talk about delayed cooling and post-harvest treatments. I won't go into it now, but just something interesting to notice, that the higher importer temperature actually reduced incidence of flesh browning. And we have developed a sort of a one-pager with recommendations concerning storage potentials and cultivars by type, so white nectarines, white peach, plum and yellow nectarine, the ones that we've studied. We provide a sea freight, flesh browning or storage disorder risk, what we consider to be maximum storage duration at 2 degrees and some limiting factors. And Christine will have more information. This is about a year old, this spreadsheet, and this information sheet, and we will be updating it. Particularly these, because we've learned a little bit more about these different varieties and what the maximum storage life is. And it is available on the Horticulture Industry Network website at the moment. So if you're interested in understanding sort of variation between varieties in terms of storage performance, then this sheet may be useful to you. Okay, so finishing off that section of the talk. So beyond the service supply chain project, this is what I believe we have to look at, and already started, but potentially new R&D, is actually benchmarking our latest new cultivars against best performing varieties. So for example, any new white flesh nectarines would be benchmarked against Flavour Pearl, which seems to be a very good and robust variety, particularly for export. And we could conduct cool storage and ripening trials, as we already have. Also, optimum harvest maturity based on fruit physiology. And there's always more work to be done there. Post-harvest treatments. Well, I've already started to look at optimum cooling practices after harvest to reduce storage disorders. I'll talk about that. But then there's a lot of modified atmosphere liners and even carton liners that are being used at the moment, and we don't really know the effect of these liners on storage performance. And then the impact of fumigation for air freight on fruit quality. We've done a little bit of work, but again, a lot more. And with temperature monitoring, as Glenn will talk about, it's interesting, we don't have a lot of data about temperatures, fruit temperatures beyond harvest, but before the freight forwarder, or after sea or air freight, into retail and export markets. Our data is limited, so it'll be interesting to find out more about that. So that's the section on cultivar performance. As I said, briefly outlining what we've been looking at during the life of this project.